So I wanted to introduce our team. This needs to be updated, but we've got a couple postdocs, Rashmi and Bernardo, that are working on the development of improving Paddock Trac. And I'm going to talk a little bit about what they're doing later on in the presentation, but I think what they're doing is pretty exciting. Some cool stuff. Of course, myself, and then we got a new person, Nathan Pig. He just graduated and started with us as a research specialist. Then we have a grad student, Usha, that works predominantly with Bernardo, working on calibrations, on equations. So trying to improve what Paddock Trac comes up with. What does it mean? How much does an inch of grass? What does that mean? So that's what she's working on. And then probably the most important guy there is our boss. He's the dean, but he tells us what we got to do, and that'd be Dr. Kallenbach. And then I wanted to add on to that, like I said, we need to update this. So we have Ashley Hughes with Dairy Grazing Apprenticeship Program. Ashley is a former student of mine. We work great together. We've worked together when she was with Grasslands, and now she's with DGA. She keeps me in line, keeps me honest. Then again, like I said, Nathan is new. And then we also just hired another kid, just graduated, Ellen. So that'll be another research specialist that we're going to have working with us. So anyway, I just want to introduce what our team looked like. Okay, so let's get started on where did Paddock Trac come from? And it was not developed or started to be something to be used for a farm. It was strictly used for us for research purposes, and mostly because we're lazy. We wanted something that we didn't have to be on our hands and knees all the time, pushing a mower or doing all the calibrations. We wanted something that was going to be easier for us. And so, like, for instance, here, this is nearly 200 plots that we would have had to take in a rising plate meter and taken so many plunks across each plot, taking cuttings and all that. We wanted something to be easier for this. And so that's how Paddock Trac was. That's not what it was called back then, but that's how it became developed. And being researchers, it had to be accurate, it had to be repeatable, and it needed to be efficient. Now, working for the government, efficiency wasn't that critical. But again, I wanted to throw that in there for a reason as we go down through here. But mostly accurate and repeatable is what we needed it to be able to do for us. And this just shows kind of, you saw these plots that I had up there before. Well, here's Paddock Trac with sensors on two ends that you're measuring 2 rows of paddocks. So that would be our plot work that we're using. And then on the left is Paddock Trac when we're using it on a system-wide, when we're looking at big paddocks. So the sensors mounted to the front of the bike, where we can be measuring big areas more efficiently. So as we presented this data that was coming from our research projects, and the farmers are actually sometimes out there in the field with us while we were collecting the data. And they said, well, we want that. That's cool. We want to be a part of that. We want what you have. And because they didn't want to be on this slide. This is a slide I stole off Twitter. This is from the UK, and this is data they'd collected. And the pile of grass on the left is from the average beef and sheep farm. The pile in the middle is the average dairy farmer. And the pile on the right is the potential yield. And our guys wanted to go from being that average to being better. And they knew they needed to do that by measuring. They needed to be able to do better decisions. And so their goal, if they could make better decisions, that meant the pre-graze was going to be right. That meant the allocation that they were going to be offering the cows was going to be right. So the utilization was going to be correct, and the residual was then going to be right. So this whole vicious circle, everything's got to be right. So you end up that 30 days later, you're doing it again. And the quality of the grass that you're giving to the cow is exactly what you wanted. But it's got to be that the first step is getting that pre-graze and that allocation correct. And so the guy said, we got to be able to do that. We need the data that says this is how much grass is here. This is what we want our intake to be. So this will be what our allocation is going to be. So that set them up all the way through the grazing season for the next round. So they had been using the rising plate meter. And so they understood what the data meant and they understood the importance of it. But they also said, God, this takes way too long. We don't want to do this anymore. Some of them also use CDAX, which is another way of measuring grass using light beams as the grass goes through it. But it has some problems going across rocks. So a lot of times it was in the air more than it was on the ground. So and the other problem we had is you're going through a paddock that cows have been in, so there's manure in it. That's spreading up all along the lines of the light beam. So you're constantly getting off the bike and going out there and wiping off CDAX so you can get an accurate measurement. So you had the efficiency part that we talked about with the rising plate meter. It wasn't as great when we wanted to do, or you got the environmental things that we had to do with CDAX. So they said, we want something better. We want to try what you're doing with your research projects. We want to use Paddock Trac. Fantastic. They have the same goals as we do, only in a different order. They got to be efficient. They're farmers. They don't have time to be messing around like we do. So they got to be efficient. It's got to be quick, but it's also got to be repeatable and it's got to be accurate. Same goals, just in a different order. So where were we at? Gosh, guys, 20, 25 years ago. This is what it looked like. This is a military ruggedized laptop. It's about a $5,000 computer. Okay, remember a long time ago, so computers weren't cheap like they are now. So a long time ago, very expensive. It would last about a year and a half before we beat it to death driving across fields. And we realized if they want something like this, they're not going to spend $5,000 on a laptop that's going to work for a year and a half, maybe two. We got to come up with a different way for this to work. And so after a lot of argument and discussion, this is what we came up with. Whether we're right or wrong, this is what we got. And we used the Fitbit model. Is that, okay, you're probably have seen this on people, or you may have it on right now. You got your wristwatch on your arm, and it's collecting the data and it's sending it to your smartphone. And from the smartphone, it then goes to the cloud and to the servers, and it waves a magic wand, does your data, and then sends it back to your laptop for you to look at, or your computer. So that is the concept that we came up with that we wanted to do. We wanted a sensor on the bike. It's going to measure the height. It's going to send it to your smartphone. Almost all of our guys had smartphones. And so that's what we went with was that was going to be the conduit to get it to the servers. And then they could upload that. And again, the magic wand was going to happen with the data that was collected, and the magic wand's going to get waved across it. And here's what comes out. The information that you need, and it goes back to your computer. So that's the whole concept. It's a Fitbit model. So the concept is easy. We're just going to run the Paddock Trac, the sensor, over the grass, and that's going to measure the height. Well, what does that actually mean? What does that inch of grass actually mean? And I'm just going to try. So you got two concepts here. You have the tear, which is the most critical measurement that we got to have. If our tear is wrong, then the height's going to be wrong. So tear is going to be the bottom of the sensor to the ground. That is the height of tear. That is the most critical measurement that we can have. If we screw it up, we're going to screw up our total height of the forage. The height of the forage is then going to be subtracted from that, and that's going to be the total height that's going to be sent to. It's an unknown unit. I shouldn't say unknown. It doesn't have like centimeters or millimeters or inches. It's a electropotential type deal that we get converted back into a height. It's 0.08, I don't know, some other number that's multiplied by this number, and that gives us millimeters. So that's how we come up with what does height mean. So trying to be a little bit humorous here. What does that actually mean? We came up with a height. We know it's right. We know that the height is right. But how do we get that into a pounds of dry matter or a kilograms per hectare? How do we get it into that measurement? What does it mean? Does 6 inches of fescue, is that the same amount of forage dry matter mass, of biomass, as brome or alfalfa or ryegrass? Probably not. Each one of those is going to have a different equation. And we've got to figure these out as we go across. That's going to be our big challenge. The heights are easy. It's getting the height converted into pounds of dry matter or kilograms per hectare. That's going to be the challenges that we're going to face. And so that's what this next slide talks about. Whether you're a satellite, whether you're a drone, whether you're a seed axe, whether you're a rising plate meter, or whether you're Paddock Trac, you better ground truth it for calibration. Just coming out with a satellite image that says, oh, this is how much pounds of dry matter you have, that ain't right. NDVI is not going to cut at one time. It's got to have ground truthing. And so that's what one of the big things that we're working with. And that's why we hired 2 postdocs that are engineers, because they're smarter than we are. And we needed that kind of people to figure this out. So hopefully these work. This is just showing, this is the picture in the upper left is our harvester, where we're harvesting big areas. So that is actually, it's measuring its own length, its own width, and then it will weigh the amount of grass that's being harvested. So we can plug that in and we can figure out how much grass is there in a square area. And then down on the bottom right, that's the way we used to do a lot of stuff is, the area, you got a 1/10 of a square meter that we're hand cutting that, again, coming up with a dry matter for an area. And then up at the top is where we're actually using Paddock Trac to measure the height before we came in and did a cutting. So this is the stuff that's got to be done to ground truth, to come up with how much grass is there, and you put it into an acre or back into a hectare. Ideally, this is what we come out of this with. This is going to be the predicted yield on the vertical axis and the actual yield on the horizontal axis. And this is the type of curve that we're looking for with an R-squared of 0.86. That says, yep, we've accounted for 86% of the variation. That's what we're looking for across the board with all these species. This was tall fescue. So this is what we're trying to come up with of having the accuracy that we know what the height is. We know the height's right. The centimeters or the millimeters or the inches is right. Now we not got to put that into a pounds or a kilograms. So the way we've decided to try to handle this is the farmers we're going to have, because of the grants that we're working with DGA, there's going to be nearly 40 farms. We've already got 8 or 9 right now. There's going to be 30 more farms or plus or more than that. So roughly 40 farms are going to be involved in this. We're going to have them help us do the calibration. And what better way of doing this, because now they've got skin in the game. They're actually going to believe what the equation says because they made it. It's not some academic that says, hey, here's the equation. This is their equation. That's what they came up with. So that's one of the reasons why we're having them do it. Plus, we need the data. So if we think about it, if we're going to have them do a spring cut, a summer cut, and a fall cut, and so that's roughly 30 cuts, and we got 40 farms. That's 1,200. That's 1,200 data points. Now we're getting somewhere with some power of how accurate we're going to be in coming up with our equation. Because most of these farms that we're going to be dealing with are mixed grass. They're going to be ryegrass, they're going to be meadowgrass, they're going to be brome, they're going to be, and so they're going to be a mixed type species that we're dealing with. Most of the stuff that we've dealt with in Missouri are monocultures of fescue or perennial ryegrass. And so what they're going to do is they're going to do their own cutting. So this is 15-foot strip, and they're going to mow with a mower with a bagger, and they're going to weigh, and they're going to look at the residual of what was below the lawnmower, and they're going to put all this together, and they're going to come up with something like this. So this is, let's say, a summer cut at Joe Tamandel up there in Wisconsin. And we had one data point that was an outlier, so we kicked it out. By doing what we're doing, we're allowed to kick out one data point. And so because of that, we come up with this equation for them with an R-squared of about 0.83. Not too bad, especially the first time ever doing this. Now think about it. Now we've got 40 other farms that we're going to overlay this data, and we're going to start getting more and more powerful. So that where the farmers are now going to be building the equation. We're going to help them, but they're going to be building the equations as we go. So how does this whole thing work? So this is just showing, I should turn off the stupid. Okay, sorry about that. This is just showing going across the paddock using the sensor, and then over on the right, you can see this is the app that's on your phone. And it's geo-referencing every data point. There are 50 readings per second as we travel across that. Every one of those readings is geo-referenced. And you have, when you built this into the grazing wedge, you have geo-referenced all your paddocks. You have put it into Google Earth as an outline for every paddock. It's not hard. It's pretty easy to do. Or you've used the internal mapping tool in the grazing wedge itself. So every one of your paddocks is outlined. So when you go across it with Paddock Trac and that geo-reference, it automatically knows where you're at. You don't have to type in you're in paddock 10 or you're paddock 20. It knows where you're at because everything's geo-referenced. Once you have collected the data and you have uploaded it, you then receive an email that says, hey, good job. You did it. You did it. You uploaded it. The data was successful. We now have it. Now we're going to be processing it here in a bit. So what you can do, you've got this email. It's going to say, hey, if you want to check that you did it right or it worked, then click on that click on the batch data. And so what comes up with this is what you just ran. The green dots are in a paddock and they're going to be utilized. They're within the parameters of a paddock you drew. The red dots are actually in the lane, so they're not within where we're going to be measuring. So they're not going to be used in any of the calculations. So this just basically allows the farmer to look at it and go, yep, that's the pattern I drew, and those are the paddocks I used. And so, yep, this is good data. Or the other way around. No, that's not it. I need to go back and look at it again. Or I need to call Ashley. Don't call Stacey, call Ashley. And because this isn't working. And so it's one of our ways of checking that making things are working right. So you've done all this, and now it's up into the server, and you help it wave the magic wand to look at the equations and that sort of thing. And what comes out of this is a grazing wedge. And it's a snapshot in time of what your farm looks like today. And it ranks the paddocks in order. So next week they may be different. It's going to put it into kilograms per hectare or pounds per acre, whatever you picked when you set your farm up. The blue line is your target. That is something you set. It's not something we set. This particular farmer said, I want to go in at 3,000 pounds per acre with my cattle, and I want to come out at, let's say, somewhere about 1,800. And you can see he's not meeting his targets. He's overgrazing. This is drought year, so I'm not going to be too critical. But this allows you to look at a point in time of where you're at. The second part of that grazing wedge is the key indicators that are coming out of your data. This new grazing wedge, nobody's seen this. You guys are the first to see it. I'll be honest. You're the first ones to see this. This is going to be released next week, I believe. We've got a couple other farms that are doing beta testing right now. And if they come back okay, which I hope they will, this is going to be released next week. So you're going to see some new data that I'm going to show you here. In the past, all you ever saw was growth rate, and that is the pounds of grass that is being grown per day per acre. Okay. But it really doesn't mean that much if you don't know what demand is. That's the new number that's coming into this. This is the new wedge. It's going to give you demand. That is how much grass you need to grow. That is stocking rate, cows per acre, multiplied by what you want their intake to be. Okay. So this was a beef farm that's looking at, so they got a stocking rate that's not a very high stocking rate, probably 0.3, 0.5, versus our dairies that we look at are 1 or 1.5. So they're going to be higher stocking rates. So the growth rates or the demands are going to be higher. So this is this is data that you have put in that's being calculated. It's going to give you the pre-grazing cover that is ideal, what you said you wanted it to be, and it's going to tell you, well, this is what you're going in at. This is what you're coming out at. It says I wanted to go in. I wanted the cows to leave 1,800 pounds, but I'm leaving 1,400. So I'm taking 400 more pounds than I want to take. And again, we're in a drought, so I'm not going to be too critical. And then again, you just look down through here. It's going to tell you the number of cows, the dry matter intake that I wanted, and that calculates everything. So it's giving you a lot of data that you can utilize when you're making the decisions. Remember, we said, if you're going to get it right, we want to have the right allocation. This is going to help you with your allocation. Everybody learns a little differently. So remember, we had the grazing wedge, we had the data table. Well, here's another way of looking at it, is a map of your farm. And every one of those is a paddock. And so you can see the paddocks in yellow that we overgrazed, the paddocks that were in light green are growing, and the paddocks that are in dark green are the paddocks that we're getting ready to go into. And then if they were red, it says they're too mature. So it's giving you a visualization of what your farm's going to look like. So we can actually look at this. If you look at here at the top, you can look at farm, paddocks, cover, grazing wedge, summary table, harvest yield. What we try to do is make it more intuitive. So if you go, I don't care about X, then don't click on it. Only click on what you want to learn more about. That's why we added this. We changed this around to make it more intuitive. So here we said we want to look at our paddocks. The acres are being calculated by what you drew into Google Earth or in the internal mapping. So you're not going to change that unless you go in and change that on Earth or on the internal map. But you can put in here, what was the species of grass that were in my paddock? And here you can say, well, it was warm season, annual, or it was tall fescue. This is on this farm. It's going to be a drop-down menu that you're going to pick from, and you can pick whatever forage species you want. And if you go, well, it's not here, then let us know. We'll add it. We can add that. Okay. As admins, we can add whatever we want to add into that. And then you can say, well, what's its status? Is it active? Are we really using it or we're not using it? Well, let's say you got a paddock, you go, well, I'm regrassing that. Well, inactive, make it inactive, because you're not going to be grazing it for 6 months. Well, don't have it being calculated into your equations. So you can make it inactive, or you're going to hay it or whatever. For whatever reason, you can add it in or you can take it out. So we go a little bit further in. So you picked your forage species that you wanted. Well, behind the scenes are going to be the equations, and the farmer's not seeing this. This is stuff, again, behind the scene. He's picking the grass. And so based on the equations that we're going to be getting from these guys that are cooperating with us in these grants, well, plus the data that we've collected, is based on the month and the date. So from January 1 to March 1, here's your equation. From March 2nd to June 14th, here's your equation, and so on and so forth. The equations are going to change a little bit based on the dates. And so every forage species is going to have its own calibration. And I'm not changing these every day. We're probably going to change them twice a year. And once we get data coming in from spring and summer, we'll evaluate, we'll go in and make adjustments, and maybe we'll adjust again once we get the fall data in. So this isn't something that's being updated every day, but it's going to be done a couple times a year as we get more data. And as we get more data, we probably aren't going to be having to do that very much in changes. But the farmers are building their own equations. So I'm bringing this slide back in of Dr. Kallenbach and Rashmi and Bernardo, our postdocs, and what are they doing. And so where were we at with our research? Okay, that's where we started. Where are we at now, the on-farm management, and where are we going with verification and validation? And that's what these guys are sort of working on to make this verification and validation. And why is this important? Well, we got some organic guys that are using this as they're going, well, this is our verification for our inspectors. It shows this is the grass we grazed, or this is what we did, or whatever. It's allowing them to show their inspector this is what's happening with intakes and that sort of thing. For our grant awards with nutrients and carbon sequestration, it allows us to validate what we've done because it's a number. That's not a made up number. So Rashmi is now working on Paddock Trac 2.0. And we're going to, you see a lot of letters over here. So we're looking at lasers. We're looking at, I can't remember what it's called, but it's the IMU, but it's allowing it to adjust based on the angles. Okay. So if I'm sitting at a tilt, it's going to account for that and correct it. It's going to have a radar. We're going to, instead of just the sonic, we're going to be having radar that's going to penetrate deeper down into the grass. So we're looking at what the structure is. GPS is going to be in it instead of in your phone. It's going to be more accurate coming from the bike or the unit itself rather than your phone. And then obviously the sonic with the Bluetooth. That's going to communicate back to the phone. Basically, your phone is now essentially going to be just a conduit to get it sent up to the cloud, to the servers. So this is what she's working on right now. Was that going to be done tomorrow? No. What we're hoping is she has it ready to go sometime, maybe next year for beta testing. But it's good. What we're really excited about is some of the things that we're going to be able to do with that. Bernardo's working with the satellite, and we now have subscription with Planet at the 0.5 resolution. So when they're doing their calibrations, remember it's all GPSed. So we're going to have a pounds per acre for what they just cut that is GPS, that he can look down at the 0.5 millimeters resolution of Planet on a daily basis and go, oh, that's what the grass looked like. So now the satellite's going to be part of the equation. And then this is something new this is a little bit above where I'm working on right now, but they're looking at bringing in UAVs with drones and using them again to look at other different types of sensors to look at the grass and try to come up with a different way of how it's going to look. So that's sort of what the future looks like with those two guys. Okay, yep. So back to the validation verification. So this would have been pre-COVID. It's kind of amazing. Everything we talk about now is all based on COVID. This would have been right before COVID. And this was off Twitter. And this was from Ireland. And they had posted that some of their farmers are going to be required to measure their grass 20 times a year. That's going to be a requirement. And so here's an example of they were going to have their measurements in February, March. Most of their measurements are going to be during the growing season of April through September, and then a few in October and November. Those are going to be requirements that the government is telling the farmers you're going to have to do. We're also seeing this happen with companies. They're wanting to validate, verify what the farmer is doing. Am I agreeing with this? No, I'm not saying I agree with it, but I'm telling you it's coming. Whether it's the government telling you what you all to do or whether it's a company telling you all to do, it's coming. And I think this is an example of that. So a little bit back to where we're at. We're at proximal sensing right now. You guys, what we're talking about is Paddock Trac. We're actually proximally out there measuring the grass. And what Rashmi and Bernardo are working on is artificial intelligence. Let's just call it what it is. They're looking at artificial intelligence with the satellites, with the geospatial stuff that's publicly available, your soil test, your soil types that are, your soil types. I have a sandy loam or I have a gravelly whatever. There's a million different ways of this public data that's out there that they can go, well, here's the farm. This is the public data that's available. Now let's use that as a variable. The remote sensing from the satellites or from the drones, the weather data that's going to be coming in, that's going to be near your farm. And all that gets put into a biomass data cube, which may run 100 iterations of all these different variables And as the variables get together and closer and closer and closer, it spits out, okay, here's what all 100 variables look like now. And this is what your grazing wedge is going to look like. And people are going to go, well, why am I doing that when I can go out there and measure it with a bike? Yeah, great question. But let's think about it from the farm that's 800 acres. They don't have time to be on a bike all the time measuring their grass. So maybe they will designate on their 800 acres, we're going to measure these 10 paddocks. Those are going to be our proximal sensing that's going to be added to the data. They're going to be the check of what this artificial intelligence in the biomass data cube is going to say, yep, this is a check, and now it corrects everything for what else is there. So instead of taking all day or maybe 2 days to measure their farm, they may spend a couple hours with their check of measuring 10 or 15 paddocks, and now they still come up with a grazing wedge based on what the biomass data cube is going to tell them. So that's where the direction we're headed right now with, as Camila and I were talking, we're going to hire some more. Are we hiring animal scientists? Are we hiring agronomists or plant scientists? No. We're hiring computer scientists. We're hiring engineers. Now, what my job is and what Ashley's job is to keep them down to earth. Make sure that what they're sending out to us is correct. Now, maybe we're not going to know if it's correct, but we're going to say that can't be. Like, for instance, they'd sent me something the other day, and I said, well, that's not right. You can't have a negative number. Okay. So that's the farm skills that Ashley and I have, that we'll be working with these guys. Because they're really brilliant on wellness kind of stuff, but they need some help on the farm side of it. So with that, Camila, I'll stop it. Maybe that's too much, but are there any questions?
Yes, thank you so much, Dr. Stacey. We have some questions on the chat, and if anyone else has any questions, please keep them coming, that we're gonna try to answer them right now. The first question we have here is a comment and then a question. So growers will probably have to set up their own calibration on their own pastures, as you mentioned. Different species composition to set up their own equation. How much area will a grower have to cover to get a good estimate? Are they gonna have to do all their pastures with the technology we have available right now, or would they be able to just cover some areas for this calibration?
Yeah, great question. And so what we're doing right now, and we're going to find out as we go whether we're right. But at the moment right now, again, we're looking at mixed species. So they're going to do 3 cuttings of tall grass, what their cows are getting ready to go into pre. And the measurement they're going to use there is the width of the lawnmower that we're using is 22 inches. And then we're doing 15-foot strip. Now, 15 foot is not a magical number. Remember, we got to measure that, its height, with using Paddock Trac to get a measurement. That's about I'm pretty good at hitting stop and start. 15 feet is about as close as I can get with hitting stop and start. So that's the reason why if you want to go 20, that's even better. But it just means you got to mow more. But 15 feet is what we've been having them do. And again, it's no magic wand. It's how good you are at hitting stop and start on Paddock Trac. So you're going to have 3 that are tall grass, 3 short grass, 3 in the middle that are going to be 15, 20 foot long, 22 inches wide that you're going to cut and weigh. And that's what's going to build your equations. Are you going to have to do that for every species? If you got a whole bunch of species, the answer is yes. Sorry. But if it's all mixed grass, it can all be as one.
We have a follow-up question for that, focusing on the mixed grass. So the swords of mixed legume grass stands probably will change in composition during the growing season, based on heat units and rainfall requiring recalibration. So again, I feel like this question of like the mixed grass, it comes over and over. I've heard other people asking that, especially because we know the cows don't graze, uniform. They will graze different species differently, and they will also like avoid some part, which is a following up question as well. Manure and urine found areas that are avoided in successive grazing sequence would probably impact the quantity of forage that is utilized by grazing animals. And I'm going to add to that, to some farmers that have a lot of like invasive species. Like, how do you account for all of that? You have to like mow everything to be able to.
Yeah, that's a great question, because it's measuring mass, or it's measuring. So if all you are is pigweed and it's measuring pigweed, that's going to give you the height. And so, yeah, it is what it is. It's measuring height. And so again, if you've got a lot of invasive species in there, it's going to be a false number. It is what it is. Now,
do you envisioning it being part of the calibration? Like if people could, cut the one, square meter thing and kind of know how much of that. I know it's not like perfect, but would you be able to use this to calibrate? Like if you have a pasture that has a lot of invasive species in the future, you think you would be able to like take this up on the equation, or, you guys are not, this is not something that you envision being part of the equation?
No, I think we can, and I think we probably will in the future, because one of the discussions we've had, and I'm not saying this is going to happen, and I'm just saying this is a discussion. Is there a sensor we can add to the bike? Yeah, the more stuff we add, that means more stuff that can break. But is there a sensor we can add to the bike that will differentiate what's out there? So can it recognize, because of color or what have you, pigweed? Can it recognize like what I have on my farm, a ragweed? Can it differentiate those weeds from grass? I don't know the answer to that. That's going to be up to somebody else smarter than I am. But that's something we've had a discussion, is can we add something to that where it can differentiate weeds versus real forage? I don't know whether we can do it or not, but that's something we're talking about. And I mean, if we can, fantastic, because then we can do exactly what you're saying. You can get back into these equations and these calibrations and pull stuff out and make the equation better. But yeah, great questions.
And I feel that would be the same concept when I know a lot of people ask about different topographies and soils and stuff. So I'm assuming that will be also something similar, right? Like as accurate as these answers become, the easiest will be to apply for different topographies and things like that, right? As we were talking earlier.
Yep.
There is a question here, and that's a good one. Will this technology be affordable and available to all farmers? Like how expensive it will be when it, I mean, I know you don't have an idea on that, but like, is the idea of that to be like affordable? And I will add to that some questions that I have a lot here in Southwest New York that we were actually talking about it before we started. How hard it is for farmers that don't have good access to internet to do the grazing wedge thing? Because I'm assuming you can do the measurements without the internet, but you would still need to upload it to like a cloud type of platform to be access the real time data, right? So how does that, do you need to have like a minimal internet to be able to use it? And how much is going to cost?
Yeah, so the internet question's good, because I would say I'm on the where I live, my farm is on the fringe of being minimal. So basically what I do is I go out and I measure my place. I'm sort of a beta tester. When they make changes in Paddock Trac, I go try to break it and tell them what works and what doesn't work. But I can't upload out in the pastures because I don't have that good enough. I don't have a good enough internet, even not using my phone. So I go out and I take my measurements and I bring it back and I make sure I get a good signal, and then I can upload from where I'm at. You're going to need a decent, probably, again, I'm fringe internet. I can, once I send it up, it's great. I can get it all to work. It takes it longer to process. because it's not the processing's taken care is being done on campus, but getting it downloaded to my place, it takes a little bit longer because of my internet. So as I was telling Camila, I had to leave my house to come down to our research farmer to give this presentation because I knew my internet at home wasn't going to cut it. But what the exciting thing is that next week I'm going to have Elon Musk Starlink or whatever it's called is going to be here. So I'm going to have good internet. So anyway, it's the same amount of money that I'm paying for HughesNet, which is satellite, which is horrible. But anyway, that's where I'll have Starlink next week. Yay me. All right, where were we at? We had asked question on the
the other question is like, how do you envision this being available to farmers once it become like commercial? Is it going to be affordable? Like what is going to look like?
Yep. So my boss, the numbers keep bouncing around. So don't hold me to this, guys, but this is what I'm going to throw out there. I'm going to think we're going to be less than $2,000 for the hardware. Okay. But there's probably going to be some type of subscription. And the reason why that there will be some type of subscription is, remember we hired these 2 postdocs. Well, we got to pay them. We just completely redone the grazing wedge. We just completely redone the app. And so we have spent, a lot of it's been grant money, but we've spent a lot of money in having the app redone. We spent a lot of money on having the grazing wedge redone, and all of that's got to be maintained. And so it costs money to maintain these apps and these websites behind the scenes. So what we've talked about is there may be tiers of what you can buy or not buy. So maybe there is a free version, maybe there is no subscription for this, but what you get is X. But maybe you want more information, so you're going to have 0 plus X. So there could be some type of subscription. I don't know what it's going to look like. That's beyond me. That's at the dean level.
I mean, but that gives us a good idea on like how this looks like.
Yep.
So there is another question here. Will silvopasture be incorporated into the system eventually, which will affect growth depending on type of trees, weather? Like, how do you think, this is a reality? We're going to have to incorporate this at some point?
Say that again, Camila.
Silvopasture, like the trees, if we have trees and that will affect the growth. Like, I feel like with the height, you probably will be able to. So the question is if we use silvopasture, which is the trees and in between the things, if that's gonna be affecting the growth, right? Because of the trees and the weather, and if this is gonna be incorporated as like another factor to take in consideration on the equation. Yeah. But I'm assuming you are gonna be able to measure that by the heights, right? If you are like calculating it by the heights, you would be able to use that in any type of system.
Yep,
right?
I think we can do that. And again, remember I said that if you've got a different grass that we don't have, well, maybe you put in there, I've got silviculture, whatever. And so you come across, we say, I need a different equation for that because I'm going to have this impact of my trees. And so, hey, we can add anything in there, but we just got to be told. What you need, and we go.
You just need people to do their own calibration, send the data so it can be incorporated, right?
Yep.
Okay. That makes sense.
Absolutely. Yep.
Okay. So there is one question here. Let's imagine this method gets to market and farmers use it to monitor their pasture. And let's say Dr. Stacey's team monitor the use of the product. Do you think we will need constant calibrations, or let's say we'll do calibrations for some years and then generalize the equations?
Yep, I think it's
okay.
So in our discussions, we think if we get a lot of good data coming in, we think it's going to get better and better. Let's say maybe you got 2 years of a lot of data coming in, but maybe you don't need year 3 to have that much. In year 4, you got even less. In year 5, maybe you don't need anything else coming in. And hopefully part of that's because of what Bernardo's working on with the artificial intelligence. So all this data coming in, he's going to have access to all that, and he's being able to make corrections. And so all of a sudden, what we hope is that, you know, we only need very minimal calibration cuts being done.
Yep.
And then by that time, maybe it's we pick some farmers and we say, okay, you still got to do this, but we'll figure out a way to pay you to get some calibration cuts. But I think in a few years, yeah, it'll be minimal. I mean, you look at what New Zealand's got, they got 30 years of data. They're not doing calibration cuts anymore.
Yep. Yeah. So can you explain how the Paddock Trac technology is installed? It's difficult to get going on a four-wheeler. Would each farm needs its own Paddock Trac, or could farmers share?
Great question. So we do have some farms that share. I should have had a picture of this on Ashley's. So if you have, let's put it this way. So some of our guys have utes, you know, side by sides.
Mm-hmm.
And so on the front of those, they have a hitch. And so we have built templates that can go from one to a different ute down the road. And on that hitch, on that template is Paddock Trac mounted. So all you got to do is have your wiring done on your bike that goes to the Paddock Trac. Others have shared bikes, ATVs, four-wheelers. So can they be shared? Absolutely. It's just, it's the cooperation of the farms, what they want to do. And again, it comes down to the tear. Make sure you've got your own tear.
On the same token, like you mentioned the calibration, you know, the first calibration needs to be very good. So I'm assuming this first calibration needs to be done in a surface that is not grass, right? It would need to be like flat surface, because I didn't, you know, I just wanted to make sure I understood.
Yeah.
The first reading would have to be on like a concrete or something like that.
Yep. Ideally, it's asphalt, concrete, you know, yeah, whatever.
Okay.
That's ideal. And if you don't have that, you can use gravel, you know, as smooth as you can get it.
We are getting to the last two questions here. So the first one is, where do you see the future with pasture management and engineering computer science? Like, what do you think it's going to be the best use of the technology? So in the same, inside the same question, I just wanted to include one thing that I was thinking is, do you think the grazing wedge at some point is going to be able to give the farmers suggestions? Because one thing that I've heard a lot of farmers saying is that when you move from one technology, from no technology to a technology that give you a lot of data and decisions, it's hard to interpret it. So I feel like if there is a suggestion on which pasture you should do, or if like a lot of pastures will pass, you know, maybe you can make hay out of some of them. So do you envision this being part of the grazing wedge, like suggestions and things to minimize the amount of time farmers will need to be interpreting the data?
Yeah.
And
how
you see the AI and engineering being incorporated to all
this is fantastic, because all you guys are doing is giving me ammunition to go back with my team. Because we've had this conversation of we get our grazing wedge, and it can have, let's use that example. We had a growth rate of 40 and we had a demand of 17. So maybe there's a pop-up that comes up that says, hey, you have 2.5 times the growth rate than you have over your demand. So here are the options you should look at. You need to, if you're feeding any supplement, you need to reduce your supplement feeding. Or if you're not feeding any supplement, maybe you need to look at, let's pull some paddocks out and let's put them into harvested forage, whether it's silage or whether it's hay. So to answer your question is, do we want to get to that point? Yes, we do. Is it something, this is going to be horrible. Is it something our legal would want us to do as a university? Probably not.
Yeah.
So that'll be something we'll have to figure out. There will be some, these are suggestions only. Because I'm sure legal would just have a cow if we were telling guys this is what you need to do off of a computer. So do we want to do that? Yeah. Do I think we're going to do it? Yeah, maybe.
Yeah. Yeah, but it's a exciting thing to think about.
Yep.
So there is a question here. I understood that NDVI was not a pertinent indicator for you. And as I saw, you are using LIDAR, LIDAR. Did I
Yep.
understand right? If it's the case, can you explain why using LIDAR rather than NDVI and other similar indicators?
Yep. So NDVI will be one of the parameters. So think about, remember, we're looking at that data cube. There may be 100 variables that's going to go into that. NDVI will be one of them. So am I saying it's a worthless piece of data? No, I'm not. I'm saying, is it something I want to use by itself? Yeah, I'm saying that. So we're trying to, so we will have NDVI, we'll have LiDAR going. There's going to be, like I said, there may be 100 different data points going into this. What are they going to be? I have no idea right now. That's a Rashmi Bernardo question, and I don't think they know the answer to that. They're still working on that stuff as well. So is NDVI something we want to use? Yes. Is it by itself? No. Does that help answer the question?
Yes.
Okay.
So, and the last is just a comment, and then we're gonna like wrap up because it's almost 1. So there is a comment here saying that Jerry Cherney at Cornell and FieldStack took thousands of pictures of alfalfa and grass hay stands as a database combined with AI to predict the percentage grass in hay stands. And I am unsure if he was successful at getting any good predictions. I'm assuming, you know, it's still, we are still starting with all the AI and things. It's a learning curve, right?
Yep.
So yeah, we have a lot to learn about predictions and AI, I'm assuming.
Yep.
Do you have any comments on that? Have you guys tried to do something similar?
So trying to figure out what I can say. We have met with John Deere because they're really interested in our technology. And some of the things that we're looking at is, I think it goes along with what you just said, is the physical property of the forage, of the grass. Alfalfa is complicated. You think about all the different structures it's got. But the physical properties that we're looking at, and I think that's one of the reasons why we're looking at radar, is we can look down into the, how do I want to call it? The forest. I can look below the top of the tree line, and we can get down in there and look at what's below that top of the trees, what's going on down there. And that's one of the things I think that Rashmi is wanting to come up with the radar piece of this, is that maybe we got a canopy of grass that's 10 inches tall, but below that first 2 or 3 inches, there's nothing there. It's all stem. There's no leaf. Well, we need to know that. We need to know that physical property. So anyway, that's kind of where we're at. I got more questions than I have answers. I'm sorry.
So we have Lynn Bliven, who is our ag educator on Allegheny County. She raised her hand, so I think you can. I don't know if I can unmute you, but if you have anything to say, please go ahead, Lynn.
Sorry, Camila.
That's fine.
I was grazing over to get the Q&As open, so.
Oh, I mean, now that you're here, you can ask
Thank you for putting this
question.
together. Yes, I didn't mean to raise my hand. Sorry about that.
Oh, okay. Do you have any questions? No, just okay.
No, I think others have picked up on it, so it's very informative, giving me a better idea, so we can share a little bit more on Friday.
Awesome. Yeah, I was going to mention that before I say thank you to Dr. Stacey Hamilton. If anyone here in this webinar is in Southwest New York or close enough, please join us in Allbirds Farm. I'm going to drop the event here. We are going to have Zen Camila with the Dairy Grazing Apprenticeship Program bringing a Paddock Trac, and then we're going to have a discussion on pasture management on the farm on this Friday. So if you have, if you are interested in seeing it in real life, please join us Friday. So with that, I appreciate you, Dr. Stacey Hamilton, for being here today. Your presentation was, very clear and very good to the point. And now I understand better about it. And I think our participants also had the chance to ask a lot of questions. So I'm gonna also send you guys on the email, Dr. Stacey Hamilton contact and the recording. And if you guys have any further questions, please feel free to reach out to me or Dr. Stacey or Ashley from the Dairy Grazing Apprenticeship or Limb Living. So thank you very much. And I'll see you guys on another opportunity. Thank you
Thanks,
so much.
Camila. Really
Thank you
appreciate
so
it.
much. I appreciate you.